Hey guys, well, what is going on? Welcome back to another video here on the channel. In this particular video, we're going to be taking a look at almost like a part 2 to a previous video that we've done. We're going to be specifically looking at, does a higher kV motor use more battery pack? However, in this video, unlike the last one we did with this topic, we're going to take a look specifically at a dyno run, and we're going to go and talk about it in the sense of this comment. This comment has a couple good points that's worth going in and investigating. The one critical point within this comment is the same RPM. So if we take the same motor as the comment suggests, and with a different kV, that's ultimately what we're trying to understand more about. And we have the same battery pack operating both of these motors. The only difference is that we're going to alter the speed so that we get the same RPM out of both of these motors. So the only thing that's really altering is the throttle input that we end up putting into our specific power systems. So essentially what I have is a couple motors. We've seen them in other dyno videos. This is a 700 kV outrunner. This is going to be the first one that we're going to bolt up into our dyno, put an 8-inch propeller on it, and spin it up, more than likely with a 3-cell. I'm debating whether I'm going to use a 3-cell or a 2-cell battery pack. More than likely, I'm going to be using a 3-cell lithium polymer battery pack because of the 700 kV motor. Once we're done with this 700 kV motor, we're going to go and swap this one out for an identical motor from the exact same series, exact same manufacturer. However, the only difference is from 700 kV, we're going to jump up to 1050. We're going to put that in the dyno, keep the same propeller, and we're going to go and change the speed so that we get the exact same RPM output from our 1050 kV motor versus our 700 kV motor. So let's go ahead and first start by installing this and running up that dyno to max power there. Here we go. We're going to power up the dyno by plugging in the battery, and we're going to start spinning it up to full throttle 100%. So as we approach there, you can see the values start to rise on the dyno. We're getting more and more electrical and mechanical power out of the system until we reach 100% throttle, which it's going to stabilize at. From here, what I'm going to do is I'm going to take 5 samples by clicking the take sample 5 times, and this will allow us to get the data that I'll show at the very end. We'll scroll down just to take a look at what the motor efficiency is showing us. Right now it's about 70% efficient. Obviously, efficiency is going to mean the difference for us. Now that we have our baseline of what the 700 kV motor puts out in terms of power and the RPM that it essentially maxes out at, we're going to go and swap that motor out for a 1050 kV motor and then bolt everything back together and run up that motor to the identical top speed there of our 700 kV motor. Here we spin up the motor now to that same 8,820 RPM mark so that we can take our 5 sample data sets, and that's what we're going to do right here as we get that set at that proper RPM. So now we're going to go and scroll down just to take a look at the motor efficiency. This will tell us the story as what's happening. So we see that the efficiency is hovering around that 63% mark. There you have it. Here's the results of that dyno with both of the results as a side-by-side comparison. We do see that the 700 kV motor ends up pulling less current to achieve the same RPM as the 1050 kV motor. Overall, from this, we can determine that the battery pack will drain faster and use more capacity for the 1050 kV motor. Now, obviously, we know that if we push the 1050 kV motor up to full throttle, if it already draws more current at a lower setting and we go and bump that throttle up to 100%, we know it's going to draw a significant more amount of current, and even at a non-equal RPM value, we're going to have more power being drawn from our higher kV motor. That's just obvious. Why? Because we're going to get more mechanical power, therefore we have to put in more electrical power to it. So a couple different scenarios we're kind of playing out here. One is the constant RPM where both motors are at the same RPM, 1050 kV motor draws more power. And if we were to push the throttle even further beyond that, we know that we're going to drain the battery much more significantly because we're going to be pulling a lot more power. And this just goes to show us that a higher kV motor is going to pull more power out from our battery pack. Well guys, that pretty well sums it up for today. I did plan on putting out a different dyno test. However, it just happened to work out this way. You're going to see that in the next video, and we're going to be talking specifically about propeller efficiency if we go and rotate the propeller in the correct direction versus if we rotate it in the incorrect direction. Obviously not something that makes sense and is impractical to actually put into practice. However, I did hear from a couple people that this is happening, and I want to show the difference as to what is actually truly happening when we look at the power output of the motor versus the actual thrust that we get out from that propeller. So look forward to seeing that video. As always, like the video. If you do, don't forget to hit that sub button so I can see you in that next video. Thanks a lot for watching. See you in the next one.